lastly today, we're going to look at dividing radical expressions. And I want to jump into example A to start this off here. So just looking at the square root of 7 divided by the square root of 2, at first glance looks like there's not much that we can do here. I could try to break down 7 and I could try to break down 2, but they're both prime numbers. So that's not going to help us at all. We're not going to find any pairs or anything like that. There won't be any cancellations or anything. So breaking those two down is not going to help at all. But there is one thing that we can do to simplify this a little bit, and it's called rationalizing the denominator, which is a skill that you will use in geometry next year. You'll kind of see where it fits in next year, but just learning the skill this year will be very helpful. So basically, if you ever have a square root in your denominator, it is not considered simplified. So if we have a square root or a radical in the denominator, we need to get rid of it. Now remember, way back when you were doing stuff with normal fractions, you could multiply the top and the bottom by the same thing, or multiply it by 1. For instance, if I have the fraction 3/4 and I wanted to change it so that it was the same value, I could multiply it by 2 over 2, or 1, because 2 over 2 is 1, and I would get 6/8. Well, 3/4 and 6/8 are the same fraction, they just look different, okay? So you can always multiply anything by 1 without changing it. So in order to rationalize the denominator, we're going to multiply this fraction by the square root of 2 over the square root of 2. And what ends up happening is, if I take the square root of 2 times the square root of 2, we know that we get the square root of 4. Or remember, if you multiply two pairs of radicals together that have the same thing, you just end up getting 2. Alright, so we get 2 on the bottom. And then on top, 2 times 7, I get the square root of 14. And that would be the most simplified version of A. Okay, so even if you can't break down your fraction for some canceling or anything like that, or pairing, you can always at least rationalize that denominator if it needs it. Alright, so let's look at B, because this one's a little bit different. Square root of 7 on top, I can't do much with that. But I can break down my 8 here. So I have 4 and square root of 2. Alright, so here's what we've got. We got the square root of 7 over. Now square root of 4 comes out to 2, so I'm going to bring that outside. And now I'm left over with 2 and n on the inside of my radical. So we've got this. Okay, now remember, we're not completely done. We want to rationalize that denominator. We want to get rid of the square root in the bottom. So I'm going to take this times the square root of 2n over the square root of 2n. Okay, and what that's going to do is it's going to give us, so now we have a pair of things that we're multiplying together. You could say, okay, well I get 4n to the second, which comes out to 2n anyways, but remember when you have a pair, it just comes out to the thing in the center, or inside the square root. So we get 2n times 2, so really on the bottom now we have 4n, and up top we have the square root of 7 times the square root of 2n, which is the square root of 14n. And there we go, we are simplified there by rationalizing that denominator. Alright, so that is all I have for you with dividing radicals, and we'll talk more about it tomorrow.